Hello everyone. Good morning, good afternoon, good evening. Today we are going to learn about OTV terminology and concept. So what is OTV? We will learn in this. So OTV is the overlay transport virtualization protocol and is based on IP method to provide layer 2 extension between different sites over any transport infrastructure like layer 2 transport, layer 3 transport, MPLS, internet, anything. So what it does, it provides the MAC routing, which can exchange the MAC reachability information between sites which are on different sites and are reachable via method of IP connectivity. So what OTV does, it provides MAC reachability information between sites over any layer 3 transports. So now what is the benefits of the OTV? So benefits of OTV. So first one is the no need for EOMPLS or VPLS circuit for layer 2 extension. No need for EOMPLS or VPLS circuit for layer 2 extension, right? Second benefit is it uses any transport, any layer 3 transport, including internet, right? Third one is helps in STP isolation. Fourth, filter BPDU, right? And this is by default. It doesn't allow BPDU to travel across the OTV sites. Fifth one, unknown unicast is not sent over overlay. So unknown unicast not sent to overlay. Sixth, ARP optimization. We will see how ARP is optimized in coming sessions. Seventh, FH RP isolation. Eighth one is any number of site can be added. Right. So these are the some benefits of the OTV. Now we will see what is the terminology related to the OTV. So in order to understand the OTV properly, we should know what is the edge device, what is the internal device, right? What is the join interface, right? What is the overlay interface? So what is the edge device? So edge device is a device over which OTV is configured. OTV configuration is done. Right? It receives layer 2 frame that has to be extended or sent across OTV, across OTV sites. Okay. And so in the diagram, we can see that this is our OTV device, right? Edge device over which, OTV tunnels are created. And this device receives the Ethernet frame, and then, OTV encapsulation is done, and then it is sent to your OTV sites. The internal interface are those interface that receives layer 2 traffic. So receives layer 2 traffic. It can be access port, trunk port, or trunk port. Okay. All L2, features works here like HTTP, Mac Learning, all etc. So here, these are the internal interfaces, right? So a host connecting here, it can send a traffic to edge device internal interface, right? And this can be an access port, this can be an edge port, anything. This can be a trunk port. Now, what is the join interface? This is your join interface. This is your layer 3 interface, right? So join interface are those interface, which are on OTV edge device, on OTV edge device that encapsulate OTV frame to IP frame. And then from there, the layer 3 routing happens from one side to another side. So you're basically Ethernet frame, normal, then it is OTV frame, and then it is your IP header. And then from the IP, the layer 3 routing is done from one side to another side. Right? Now it can be a layer 3 interface or sub interface. Okay. Joint interface are associated with OTV, overlay interface. Associated with OTV overlay interface. So that once a Ethernet frame is reached to edge device will send to OTV interface. This is your OTV interface, logical OTV interface is there. There, your Ethernet frame is encapsulated with the OTV header. Right now, the join interface is associated with the OTV interface. So join interface will forward this packet to your join interface. Join interface will encapsulate it with the IP header, and then it will send across your layer 3 sites. Now, join interface, it discovers the OTV edge device. Discovers the OTV edge device. After discovery, OTV adjacency is formed, and then overlay tunnel is created between sites. Okay. Join interface are used to send and receive the MAC reachability information. Send and receive MAC reachability information. Okay. And these are also used to send unicast and multicast traffic. Okay. Now comes the overlay interface. So overlay interface are, this is a logical interface. So just like an interface VLAN, we configure it in a normal core switch or distribution switch. Likewise, a logical, overlay interface is configured on edge device. It is a logical interface. It consists the information of control plane, ASM group for multicast infrastructure, data plane SSM group for data plane traffic, VLAN that has to be extended, right? So all VLAN 10, 20, 50, 40 that has to be extended. Those VLANs that are needs to be extended between sites that are configured here, and then the information of join interface, to which a layer 3 interface, my OTV header is to be sent, that can be further encapsulated to the IP frame. Okay. And then last one is that, it encapsulate Ethernet frame to OTV frame, and send to join interface. Okay. Now let's talk about the OTV function consideration. So in order to see how OTV works and how the data traffic is sent over IP transport, destined for remote sites, OTV creates a control plane, and then using the control plane, the data plane is used. I mean, the data is sent. Now there are two types of infrastructure in the OTV environment. One is the multicast infrastructure and one is the unicast infrastructure. So we will see how using the multicast infrastructure and the unicast infrastructure, the traffic is, I mean, the control plane is created, and then using the control plane, data traffic is sent. So thank you for watching OTV terminology and concepts. Thank you very much. Take care. Bye bye.